As my dedicated viewers will know by now, my tastes in videos run toward the long, and, I hope, deep. This does, however, mean that I tend to focus my researches on topics with the most information. In other words, older discoveries and well-established ideas. As such, I don't tend to follow my esteemed colleagues in the YouTube space community in posting quick updates about new discoveries. So I thought I could remedy that somewhat by doing a year-end check of all the most interesting discoveries beyond Earth this year. Keep in mind, this is a very personal list, and very much reflects my own interests. So you'll find little about dark matter or dark energy here, but a lot about planetary science and astrobiology. I'm sure the more traditional astronomy news sources will gear their end-of-the-year lists to more general tastes come January. So here is my very biased selection of the 10 most interesting space-related discoveries of 2017. Titan, both more Earth-like and less. This is as much a mea culpa as a top 10 entry. In my episode on Titan, I noted that astrobiologists had modeled an alternate cell membrane capable of surviving in a liquid methane environment based on a molecule called acrylonitrile. What I didn't say, because I didn't know, was that acrylonitrile has been discovered this year in the atmosphere of Titan. A pretty stunning endorsement of an idea that until then had been pure speculation. Not only that, but the substance had been found in large enough quantities to play a significant role in any potential Titanian biochemistry. Conversely, other studies this year have revealed Titan to be less Earth-like in nature, since its rivers show none of the telltale signs of having been shifted by tectonic plates, suggesting that Titan, like Mars, never had an active plate tectonic system like Earth. The origin of Titan's Earth-like mountains, which resemble those uplifted by plate collisions on Earth, remains a mystery. Moon mysteries. From a grand perspective, our moon is not perhaps the most interesting place in the solar system, and given how much we know about it, you'd think that there'd be little left to learn. But it is still capable of surprising us. For instance, scientists learned this year that the moon very likely had an atmosphere early in its existence. The black plains of the moon's surface have long been called maria, or seas, even after we learned that they were not of flowing water, but frozen lava. But these giant lava flows, as they erupted billions of years ago, would have released vast quantities of gas, granting the moon a temporary atmosphere. Also this year, studies of the splash material from the Aitken Basin, the largest and deepest of the moon's impact craters, have given planetary scientists a glimpse of the moon's upper mantle. Earth's upper mantle is composed largely of a mineral called olivine, with flecks of a mineral called pyroxene. But astronomers found that the moon's upper mantle was composed largely of pyroxene. Given that the moon is believed to have formed from the Earth, this is somewhat surprising. In July, another glimpse into the moon's past was proffered by the somewhat obscure element gallium, a metal so volatile that it melts in your hand. The moon is exceptionally low in volatile substances, and by examining large sets of lunar samples, astronomers were able to show that the moon likely lost its volatiles globally and in a very short period of time, when the surface of the moon was one vast magma ocean. Finally, global analysis of pyroclastic flows on the moon's surface has revealed that its interior is far richer in water than originally supposed, offering yet more hope to any potential colonies. A galactic living fossil. A telescope, as anyone with a layman's grasp of astronomy knows, is a time machine. When you look out at distant stars, you are seeing them as they were hundreds, millions, or even billions of years ago. And our deepest gaze into the abyss of time came when the Hubble Space Telescope's stare penetrated into a tiny region of space, now known as the Hubble Ultra Deep Field. At the very edge of its vision, Hubble saw galaxies as they were when the universe was just 7% its current age. Strange, globulous dwarf galaxies, much smaller than our own, poor in anything other than hydrogen and helium, but ablaze with star birth. So it was quite a shock in March when astronomers at the Arecibo Observatory in Puerto Rico found just such a primordial galaxy, all of 50 million light-years away. This is not dissimilar to finding a dinosaur wandering around Tokyo, so there is more than a little speculation as to how it could have happened. The current going hypothesis is that the small galaxy, less than 1,000 light-years across, recently collided with a giant cloud of hydrogen, which effectively rejuvenated it by not only reducing its relative amounts of elements heavier than hydrogen and helium, but also providing a burst of new fuel for star formation. Needless to say, astronomers are drooling to get a look at this thing, since it provides an accidental glimpse into the formation of the universe itself. The WOW signal solved? For decades, the WOW signal has been the closest our species has had to evidence of extraterrestrial intelligence. It was first and last heard on August 15, 1977, at the Ohio University's Big Ear radio telescope, by a volunteer named Jerry Eman, who was so astounded by what he saw that he wrote the word WOW in the margins of the printout, giving the signal its name. The signal was 30 times more powerful than normal, and lay within the frequency for the wavelength of hydrogen, exactly where SETI's optimistic formulators had suggested benevolent aliens would place any friendly messages. But despite decades of trying, no one has been able to relocate it. Then, in 2016, Antonio Paris, a professor of astronomy at St. Petersburg College, Florida, suggested that the hydrogen signature detected could have been from one of two then undiscovered comets, Comet Christensen and Comet Gibbs, which, the calculations show, were within the Big Ear's line of sight at the time. Since the comets were expected to return in late 2016 and early 2017, if their signatures prove similar to the WOW signal, that would provide strong evidence, if not conclusive proof, of its origin. Well, they did return, and, according to Paris and his team, they did indeed match the WOW. It was substantially weaker, but Paris argued that this was due to the smaller size of the radio telescope used to track them, and also because comets decrease in size as they orbit the Sun. So is the WOW signal finally solved? I doubt any evidence could conclusively solve it, and nothing would ever stop the dreamers. But this does perhaps shift the WOW signal somewhat from the paranormal to the mundane end of the spectrum. I, for one, find that both sad and a bit of a relief. Another ninth planet? Those of my viewers who watched my video on Planet 9 will know that speculation has raged for decades about the so-called Kuiper Cliff, the sudden dramatic fall in the numbers of Kuiper Belt objects at about 50 times Earth's distance from the Sun. Models for the formation of the Kuiper Belt, a ring of icy objects beyond Neptune that includes the former planet Pluto, had suggested that numbers of Kuiper Belt objects should increase dramatically beyond 50 times Earth's distance to the Sun, so the reason for the cliff's existence remains a mystery to this day. A mystery that astronomers Kat Volk and Renu Malhotra believe they can solve by invoking a ninth planet. Not Planet 9. That supposed object, if it exists, is so far away that it would have about as much to do with the Kuiper Cliff as a barista in Bangkok would have with a New Yorker's missing car keys. No, this planet, sometimes conveniently, if somewhat erroneously called Planet 10, would be far closer to home, and far smaller, about the size of the Earth or Mars. This year, Volk and Malhotra found what they believed to be another piece of evidence for their planet, or planetary mass object, as they call it, since they assume it would not have cleared its neighborhood sufficiently to meet the current definition of planet. Out to the Kuiper Cliff, the Kuiper Belt objects appear to be in line with what is termed the invariable plane of the solar system, the average inclination of all the planet's orbits. Once you went beyond the Kuiper Cliff, the few scattered objects within that realm had their orbits warped by as much as 8 degrees. Malhotra contends that there is only a 1 to 2% chance that this anomaly is due to sample bias. The most likely explanation, she contends, is a Mars-sized object lying at around 60 times Earth's distance from the Sun, orbiting in an 8-degree inclination to the invariable plane. We can only hope that her optimism proves well-founded when the next generation of survey telescopes, such as the Large Synoptic Survey Telescope, finally come online. Is Ceres a water world? Let's face it, as potentially habitable worlds go, Ceres isn't quite as sexy as Europa, Enceladus, or even Titan. Dwarf planet it may now be, but from a geological standpoint it kinda looks like a not particularly interesting version of our moon. Except for those spots there. What are those things? Well, now they have names. The big one is called Cerealia Facula, and the smaller one, Venalia Facula. The 92-kilometer crater therein is called Occator. In fact, Ceres is littered with dozens of these bright spots. Cerealia and Venalia are just the brightest. And planetary scientists at last know what they are. Salt deposits, primarily magnesium sulfate and sodium carbonate. Not only that, but the patterns of their distribution suggest that they were formed via eruptions from beneath their surface, making Ceres the closest object to the Sun to display cryovolcanism. The team concluded that the impact that created Occator 34 million years ago must have opened a fissure that triggered an ongoing series of eruptive events that perhaps continue to this day. Judging by crater counts, Cerealia and Venalia are unlikely to be older than 4 million years, and a persistent haze observed near the bottom of the crater is believed to be water vapor sublimating from ice exposed below. Another study used gravitational measurements to determine Ceres' internal structure, which found that the brightest and highest points on Ceres are all associated with regions of lower than average surface gravity, indicating that they may have less dense interiors, which could possibly be a sign of active cryovolcanism. Another study found that Ceres' surface features have relaxed and spread out over time, indicating that the world's crust must lie over a more flexible inner layer, possibly a liquid one. Enceladus, looking more like home. I kinda have a grudge against Enceladus. It's almost impossible to fully grasp just how tiny this mini-moon of Saturn actually is. There are dozens of Kuiper Belt objects larger than Enceladus. There are asteroids larger than Enceladus. Enceladus could fit inside our own moon 327 times. How dare it usurp the title of most likely object in the solar system to shelter life beyond Earth from poor, neglected Europa. And yet, over the course of the Cassini mission, that's pretty much what it did. Not only did Cassini learn that Enceladus was erupting cryovolcanic plumes from its south pole, but that the source of these plumes was not a single puddle, but a global ocean of liquid water, just like on Europa, but easier to get to. In fact, in 2015, in one of its more rakish moves, Cassini actually flew through one of the plumes to sample its chemical makeup. And now, 2 years later, because science is slow, planetary scientists have detected molecular hydrogen in the water plume, a discovery that, frankly, blew their minds. Molecular hydrogen isn't something that just happens. It is exceptionally reactive. Just ask this guy.
It's a terrific crash, ladies and gentlemen. The smoke and the flames now, and the flame is crashing to the ground, not quite to the mooring mast. All the humanity.
So, wherever you find it, you can be sure it won't be around for long. That means that there must be a constantly replenishing supply of hydrogen somewhere under the ice of Enceladus. And that could only mean volcanism. Our own Earth is peppered with undersea volcanic vents spewing hydrogen into the water that is then fed on by chemosynthetic microorganisms. Thus, we now know that Enceladus has all the necessary ingredients for life to exist. Which, frankly, is a bit strange. Like I said, Enceladus is ridiculously small. There is no way that any source of energy could be derived from within the moon itself. The only logical alternative is tidal heating, the same process that keeps Europa's ocean liquid. But simulations have suggested that Saturn isn't tugging Enceladus hard enough to generate sufficient tidal friction. And then, in November, scientists ran a model based on Cassini's findings regarding Enceladus' core, which has suggested that it was not solid, but essentially a pile of rocky, gravelly grains. When computer models applied tidal flexing to the broken pile at Enceladus' core, they found that the friction between the colliding rocky shrapnel produced just enough heat to keep the moon's oceans liquid, potentially, for hundreds of millions of years. Curse you, Enceladus, for making Europa seem boring. Ross 128b. It'll never work, cried the naysayers. Proxima b could never support life. Even if life had managed to get a toehold on its surface, the flares and radiation spewing out of Proxima would have rendered it sterile. Well, personally, I've never been completely sold on that. There's no reason Proxima b couldn't have a perfectly adequate magnetic field to deflect such stellar attacks. But even so, in 2017, along came Ross 128b to shut them up. Ross 128, like Proxima, is a red dwarf star, although about 30% larger and 40% more massive. Like Proxima, it is relatively close, at just 11 light-years, or less than triple Proxima's distance. It is also old, perhaps twice as old as our Sun, being relatively poor in the elements heavier than hydrogen and helium, indicating it must have formed in the earlier eras of the galaxy, when such materials were less common. But what really excites astronomers about Ross 128 is that, unlike Proxima, it is relatively calm, flaring only occasionally. This makes Ross 128b, the Earth-sized planet discovered this year in the inner edge of its habitable zone, a far luckier planet than its closer sibling. Ross 128b, which was found using the European Southern Observatory's High-Accuracy Radial Velocity Planet Searcher, or HARPS, is even more Earth-like than Proxima b. While that was a giant super-Earth, Ross 128b is only about 1.4 times Earth's mass and would be very close to it in size. Its closeness to its star, its orbital period is even shorter than Proxima's, at just 9.9 days, and relatively circular orbit mean that it is very likely in captured rotation. One of its hemispheres is in eternal daylight, another in eternal night. While it hasn't been conclusively established if Ross 128b is too close to be in the habitable zone, the amount of light it receives from its star, at 38% above Earth, is still far lower than the over 80% more received by Venus. Its planetary equilibrium temperature, i.e. the temperature assuming it has no atmosphere, is believed to be somewhere between minus 60 and 20 degrees Celsius. For comparison, Earth's equilibrium temperature is minus 18 degrees Celsius. So obviously, the error bars still need some narrowing. Still, if that wasn't enough, in April, astronomers at the Harvard-Smithsonian Center for Astrophysics identified another planet within a similarly quiet red dwarf's habitable zone. Called LHS 1140b, it receives about half as much sunlight as Earth, and lies a still fairly proximate 40 light-years away. It appears that potentially habitable worlds are far more numerous and closer than we could have hoped. The worlds of TRAPPIST-1. TRAPPIST-1 is an unassuming little thing. A red dwarf star about 40 light-years away, in the constellation Aquarius, it is even smaller than our considerably titchy neighbor, Proxima Centauri. When it was discovered in 1999, it was promptly granted the auspicious designation 2MASS J230629228/0502285 and filed away. It was a 2015 study by the Transiting Planets and Planetesimals Small Telescope, or TRAPPIST, a telescope in Belgium, acronamed for a local beer, that would grant it both its name and its fame, because it observed 3 roughly Earth-sized planets in orbit around it. Since this was the first exoplanet discovery made by the telescope, and since the star was now infinitely more interesting, the team rechristened it TRAPPIST-1. Since the planets were transiting their star, it was possible to glean information about their atmospheres, and in 2016, observations by the Hubble telescope revealed atmospheres on 2 of the observed planets, bringing the total number of terrestrial extrasolar planets known to have atmospheres to 3. Unfortunately, it was fairly clear from the start that at least 2 of the 3 planets orbited too close to their star to be habitable. The third, TRAPPIST-1d, was considered a solid maybe. And then, on February 22, 2017, TRAPPIST-1 became an international celebrity. That day, astronomers around the world announced that the Spitzer Infrared Space Telescope had revealed that TRAPPIST-1 had not 3, not 4, but 7 Earth-like planets orbiting it, 3 of which were considered to lie within the star's habitable zone. the planets within the TRAPPIST-1 system orbited about as closely to each other as the satellites of Jupiter, which would certainly make their night sky as interesting. Their orbits were so close, in fact, that astrobiologists calculated that any life present on any one of TRAPPIST-1's planets could migrate to every other planet via asteroids. Because they orbited so closely to one another, the planets had noticeable gravitational effects on each other, which meant that, unusually for transiting planets, their masses could be determined. The planet most squarely within the habitable zone, TRAPPIST-1e, could be about the size of the Earth, give or take a more than 90% margin of error. It has an equilibrium temperature of minus 22 degrees Celsius, 4 degrees off that of Earth. The next one out, TRAPPIST-1f, has an equilibrium temperature of minus 54 degrees Celsius, about the same as Mars, which could still be habitable with some added greenhouse gases. Its mass is better determined and is roughly between that of Mars and Earth. However, while the other planets in the system are of likely Earth-like composition, F is far less dense and could be up to 25% water. The planets orbit in a chain of resonances that ensure that their gravities don't interfere with each other. The pattern of ratios is so perfect that it has even been converted into music. Eat your heart out, Pythagoras. There is, of course, a caveat. TRAPPIST-1, unlike Ross 128 or LHS 1440, but very much like Proxima Centauri, is a flare star, meaning that its surface frequently erupts in violent bursts of UV radiation that could potentially erode any atmospheres around life-bearing planets. Models have suggested that at least the innermost two planets would have had all of their water broken into hydrogen and oxygen and boiled away, though it is still possible for water to have been retained by the outer planets. TRAPPIST-1 is known to be much older than our Sun, perhaps even twice as old, so life has had far longer to establish itself there. The planets of TRAPPIST-1 will be catnip for the James Webb Space Telescope, which, assuming the existence of a benevolent God, will be successfully in place next year. The Webb will use spectroscopy to analyze the atmospheres of transiting planets, and is geared to study planets much farther away than TRAPPIST-1. Could we be less than 2 years away from finding the first planets with extraterrestrial life? Rendezvous with Oumuamua. In Arthur C. Clarke's novel Rendezvous with Rama, an asteroid from interstellar space with an exceptionally fast rotation period reveals itself to be a massive, cylindrical, abandoned alien spacecraft 40 kilometers long, which then slingshots around the Sun, leaving our solar system for parts unknown. So you can imagine the thoughts that crossed the minds of the survey team of the Pan-STARRS telescope, most, I am sure, at least casual Clarke fans, when what they had initially taken for a comet revealed itself not only to be an asteroid from interstellar space, but at least 10 times as long as it was wide, on a slingshot trajectory around the Sun, possessed of an exceptionally fast rotation period of only 9 hours, and, given that, likely composed of remarkably strong material, such as rock or metal, or its spin would have torn it apart. We barely had time to acknowledge our first recorded visitor from the interstellar void, before it saw fit to leave us. Discovered on the 19th of October by a team operating the Pan-STARRS survey telescope on Haleakala, it was already speeding away from the Sun, and was moving at such a pace, 23 kilometers per second, or slightly more slowly than Earth, that it would be beyond detection by even our most powerful telescopes as soon as mid-December. On the 25th of October, the team announced the discovery of a new object, 2017 U1, and requested that any interested parties please determine its trajectory. A 2-week observation arc showed that its trajectory was strongly hyperbolic. The object had shot round the Sun within the orbit of Mercury, and in the process reached a maximum speed of 86 kilometers per second, just over the 80 kilometers per second or so needed to escape the sun's grasp at that distance. The only way it could have approached the sun at that speed would be if it arrived from beyond the solar system. The team thus assumed it to be a comet, since until then only comets had shown hyperbolic trajectories. However, despite coming close to the sun, the object showed no coma or tail, and so would have to be composed almost entirely of non-volatile materials. As such, it was then reclassified as an asteroid, the first comet ever to be so redesignated. After initially granting the object the cometary designation of C 2017-U1, and then the asteroidal designation of A 2017-U1, the IAU realized that this extraordinary visitor was something entirely new, and required a new classification. 1/I 2017-U1. I for interstellar, and 1 because it was the first of its kind to be found. A rare thing Clark could not predict was that, rather than the Hindu pantheon accepting the burden of solar system nomenclature once the vein of classical myth had been mined, that role would be taken by Polynesian mythology. Such is the cultural dominion within astronomy of the great citadel of telescopes atop Hawaii's mountains. Thus, rather than the concise Rama, this puzzling entity would be christened Oumuamua, a Hawaiian word meaning scout, or, more precisely, first to reach out. Oumuamua's path points back toward the constellation Lyra, and the bright star Vega, which, by maddening coincidence, was also the first star ever found to have an extrasolar asteroid belt around it. Physically, Oumuamua is unlike any object in our solar system. Although its albedo is too imperfectly known for precise estimate, astronomers believe it is 200 to 400 meters long. Telescopic observations show that it varies in brightness over regular intervals, a trait indicating that it is an elongated object spinning along its short axis. But its spin is so rapid that to remain intact, it must be composed of very dense, strong materials, such as rock or metal. It is also almost literally pitch black, with a reflectiveness akin to freshly dried asphalt. Those features in themselves are hardly remarkable, and in fact place Oumuamua squarely within a large family of asteroids in our solar system. But the observations also suggest that it must be roughly 10 times as long as it is wide, something nothing in our solar system has even come close to being. The most elongated objects in our solar system are about 3 times as long as they are wide, and all are contact binaries, objects that have not quite collided and stuck together. Oumuamua is highly unlikely to be a contact binary, as its rapid rotation would rip it apart. Some speculate that it might be a shard jettisoned from a massive impact. So, a 200 to 400 meter long object from interstellar space with a bizarrely elongated structure that might be made of metal? Yeah. Thoughts are turning the way you're thinking, and not just the space nerds like me either. In fact, the Breakthrough Listen project, a privately funded SETI operation, is planning to use the birthplace of SETI, the Green Bank Telescope in West Virginia, to scan the object for any potential signals. In a press release, they said, quote, "Researchers working on long-distance space transportation have previously suggested that a cigar or needle shape is the most likely architecture for an interstellar spacecraft, since this would minimize friction and damage from interstellar gas and dust." I must say, I doubt they're likely to succeed, even if it is an alien ship. Oumuamua's tumbling spin is almost certainly not intentional. The only reason to spin a ship is to generate artificial gravity, and that rate of spin wouldn't provide gravity for a space crew unless they were the size of skyscrapers. Most likely, it is a fairly run-of-the-mill asteroid that happens to be weirdly shaped and from beyond our solar system.
But even that seems a bit odd.
I mean, where did Oumuamua come from? Well, simulations have shown that Oumuamua and others like it could be far more common than you'd think. The violent formations of planetary systems from accreted rubble would send billions of these rocks into interstellar space, where they would drift aimlessly until caught in another star's gravitational hold.
Ronin of the sky, owing attraction's allegiance to no one lordly sun,
in Percival Lowell's words. A description I prefer to that chosen by the authors of the simulation, sola lapis, or lone stone. In fact, calculations show that there should be more interstellar asteroids in our local cubic parsec of space than there are comets in our solar system's Oort cloud, meaning that about 10 of these objects could pass inside Earth's orbit every year. We likely only saw Oumuamua because it came unusually close to the Earth. Future survey telescopes, again like the Large Synoptic Survey Telescope, could very well make such discoveries routine. So what now? Is there a way to get to Oumuamua? Could we send a probe there? The short answer is no. It takes years, not weeks, to plan and execute an interplanetary space mission. And even so, such a spacecraft would have to be traveling faster than any we've ever launched to catch up with Oumuamua. Less than 2 weeks after its discovery was announced, a group called the Initiative for Interstellar Studies proposed Project Lyra, suggesting that a launch date of 10 years from now and a 15-year mission time might be enough to fly by the object when it reaches the neighborhood of, say, Eris. It also suggests, however, that current pie-in-the-sky ideas, such as the laser-powered sails proposed by the Breakthrough Starshot project to reach Alpha Centauri, would be the best way to reach Oumuamua in less than 20 years. Perhaps a better option than either of them is to simply build a spacecraft capable of reaching an interstellar asteroid, and then hold it in reserve until another one shows up. So, no, sorry. Whatever message Oumuamua had for our race, even if it was just, "Hey, I'm a rock," it chose entirely the wrong time to deliver it. So there you have it. Possible cryogenic life.
An asteroid with volcanoes.
Potential second Earths. A garden of habitable worlds. And a seemingly benign alien invader. All in all, a fascinating year to be a space nerd. Please continue to be nerdy with me as we move into whatever 2018 has in store. And don't forget to hit me up on Facebook and Twitter. Links in the description. Thanks.